Okay guys, let's gather around. So since our exam is next week, we should start studying already. So let's start with Graham law and the backgrounds of Graham law of diffusions or of effusions. Graham's law, which is popularly known as Graham's law of effusion, was formulated by Thomas Graham in the year 1848. Thomas Graham experimented with the effusion process and discovered an important feature. Gas molecules that are lighter will travel faster than the heavier gas molecules. According to Graham's law, at constant pressures and temperature, molecules or atoms with lower molecular mass will effuse faster than the higher molecular mass molecules or atoms. Thomas even found out the rate at which they escape through diffusion. In other words, it states that the rate of effusion of a gas is inversely proportional to the square root of its molecular mass.
So to know more about Graham's laws, let's first differentiate diffusion and diffusion. Diffusion is a phenomenon where there is a movement of one material from an area of high concentration to an area of low concentration. This means that particles and molecules spreads throughout the medium. For example, if we spray at one end of the room, you would probably smell it at the end of the room. This is because of the diffusion phenomenon. While effusion is a process of which air escapes or leaks through a hole whose diameter is considerably smaller than the mean's free path of molecules. Under these circumstances, all the molecules which reach the hole will pass through, as collisions between molecules in these places will be negligible. A common example of effusion is the loss of gas inside a balloon over time. The rate at which gases will effuse from a balloon is affected by a number of factors. One of the most important is that frequency with which molecules collide with the interior surface of the balloon.
So, how is Graham's law calculated? Remember, Graham's law states that the rate of diffusion or effusion of a gas is inversely proportional to the square root of its molar mass. So, the formula can be written as R1 divided by R2 equals the square root of M2 divided by M1, where R1 is the rates of diffusion of or effusion of gas 1, and R2 is the rates of effusion or diffusion of gas 2. So respectively, this 2 is measured of moles per unit of time. Next, the M2 is the molar masses of gas 2 and the M1 is the molar masses of gas 1. So as what I've said a while ago, the rate of diffusion or effusion of a gas is inversely proportional to the square root of its molecular weight. That's why the first here is the M2, which is, it is inversely proportional.
So in order for us to understand Graham's law of diffusion, we need to solve some problems first. So in problem 1, we need to solve the rate of diffusion between argon and krypton at 25 degrees Celsius. So in order to solve that, we need to write off the formula first, then the given. So in order for us to find what is the rate between the two gases, we need to find the molar mass of gas 1 and gas 2, which is argon and krypton. Argon is 39.9 grams per mole, while krypton is 83.8 grams per mole. So we need to divide 83.8 by 39.9. Square root is equal to 1.45. It is already round off to the nearest hundreds. So therefore, argon is 1.45 times faster than krypton. On problem number 2, we need to find the identity of the unknown gas. Argon diffuses at 1.45 times the rate of an unknown gas. So first, we'll write off the formula, then we will replace the formula by the given in the problem. So argon is 39.9 grams per mole, which is the molar mass, and the rate for gas 1 is 1.45. So, therefore, 1.45 over 1 is equal to the molar mass of gas 2 divided by 39.9 square root. We need to transfer the square root to the left side. So, therefore, it became 1.45 over 1 squared. So, the result in the left side is 2.1. And we need to multiply both sides by 39.9, which is the molar mass for argon. On the right side, we need to cancel both 39.9. And the result on the left side is 83.89. Therefore, the molar mass of gas 2 is 83.89. We need to base it on the molar mass to find the identity of the gas. So, the nearest gas that almost has the same molar mass is krypton. Therefore, the unknown gas is krypton.